Hey guys, it's Ab. This is my AP chemistry project. I'm using the process of emulsification, which is the technique of suspending two liquids together that normally don't mix. In this case, I'll be using vegetable oil and citrus juice from a vegetable called kalamansi from the Philippines. Of course, you can see right here I'm not making the sauce. I'm actually making the chicken katsu, which we're going to use to dip into the sauce. So the history of emulsification dates back to the mid-1700s with the invention of mayonnaise. You can tell it's kind of thick, and it became a cornerstone of modern cooking because it allows chefs to create rich, creamy textures without using heavy dairy, which, some people, like me, are lactose intolerant, so that won't cut it. On a molecular level, I'm using an emulsifier, which is the lecithin from egg yolks, to bridge the gap between oil and water, because oil no le gusta water. Lecithin molecules have a hydrophilic head and a hydrophobic tail, so these tails bury themselves into the oil droplets while the heads stay in the water in the calamansi juice. And this prevents the oil droplets from clumping back together, keeping the sauce stable. Regarding physical changes, I'm basically changing the viscosity of the two liquids, and they're transformed into a semi-solid cream. And physical property just involves the interfacial tension, so the emulsifier lowers the surface tension between the oil and juice. Alright, enough of the chicken katsu. Now I'm going to actually be making the sauce so you guys can see what I'm talking about. So again, the main chemical at work is the lecithin, which is a phospholipid found in the egg yolks. I'm also using the acetic acid from the vinegar and citric acid from the calamansi juice to provide the aqueous environment so that the emulsion can form. Here you can see me getting my lecithin-filled eggs. Ooh, yes. So for the actual process, the key is slow addition of the oil and shearing. So I must add the oil drop by drop, like literally drop by drop, while whisking or blending at really high speeds. This basically breaks the oil into microscopic droplets so that the lecithin can surround them before they have a chance to separate again, which you'll see soon. Also, I know there's a billion eggs in this dish, and I don't plan on feeding this to Kathleen. Okay, I made her a separate one so that she can not starve, because I love her and I actually don't want to kill her today. So okay, so here you can finally see me whisking the sauce using a fork. But when I first started using the fork, the mixture wouldn't thicken up like how I wanted, and this is actually because the fork doesn't provide enough kinetic energy to create the necessary shearing force. So on a molecular level, the vegetable oil needs to be broken down into millions of microscopic droplets so that the lecithin molecules from the egg yolk can coat them, which you'll see in a second. Okay, so you can clearly hear and see that it's not thick enough, so you can literally see it start to form once you put more force into it. You'll see at the end how creamy it is. Oh my gosh, I'm over here thinking Kathleen would literally die if she ate this. Anyways, look how creamy it is, see? So I'll be adding hoisin sauce so I can make it better, and I'm also going to show my process of packing it so that you guys can see how hard I worked for this and how much I love you guys. Here I am. I'm finally taste testing it so you guys don't know it's poison. It's decent. Thank you for watching.